Can you see the screen? Okay, so they're saying trigonometric functions right angle approach. Trigonometry of a right angle. Right triangle. So now the objectives is that at the end of this, you have to know what trigonometric ratios, special triangles. They say calculator. I don't want you to use a calculator. The application of trigonometry of right angles. And then now you have the trigonometric ratios. Do you remember these ones, guys? Consider the right triangle with theta as one of its acute angles. The trigonometric ratios are defined as follows. Is there anyone who forgot?
Oh, it's SOHCAHTOA.
Yes. SOHCAHTOA. Opposite over hypotenuse. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. This is SOHCAHTOA. Now, because we know cosec is 1 over sine, it means it's the reversal of the sine. So it will be hypotenuse over opposite, sec will be hypotenuse over adjacent, and cot will be opposite over adjacent over opposite. Now, do you remember? Are you sure you know the position? Opposite just means if you are on this angle. Opposite, if you draw a line, that will be your opposite. And then next to you, but not the hypotenuse, is the adjacent. We are all comfortable with this one, isn't it?
Yes, ma'am.
Yes, ma'am.
Nothing to teach.
Yes.
So they say the symbols we use for these ratios are abbreviation for. So they're telling us we are using cosec, sec, cot, sine. Those they're abbreviation for sine, cosine, tangent, cosecant, secant, and cotangent. Since any two triangles with theta are similar, these ratios are the same regardless of the size of a triangle. Meaning that even if you have a small right angle or a big triangle, SOHCAHTOA will always be SOHCAHTOA. Now they say find the 6 trigonometric ratios of these angle for the angle theta. Can you do that fast?
Yes, ma'am.
So let's start with what? So the first, because they say 6, the first one will be?
Sine.
So sine theta will be equals to what?
Opposite over hypotenuse.
So it's up over hype. So meaning that this will be?
2 over 3.
Thank you. The second one, let's go to cos theta will be adjacent over hypotenuse. So it will be equals to?
Square root of 5 over 2.
10 will be, the third one is 10 theta.
Over 3, ma'am.
So this will be?
It's 2 over square root 5.
Now the other ones can be found from this one. So we know cosec will be?
Number 2 is over.
Ma'am,
Yes.
it's going to be root 5 over 3, not root 5 over 2.
You're saying what? It's what?
Root 5 over 3, ma'am. Not root 5
root
over
5,
2.
yes, over hypotenuse. Thank you. Okay, thank you. Cosec theta will be what?
1 over
3 over 2.
Thank you. And then cot theta will be what?
Root 5
Root 5
over 2.
over 2.
What's the name of the person who just answered now? The lady. Sakani. Yes, I didn't hear your voice today.
Yeah, I'm only joining now. I was at
Sakane who?
Sakani Ngobeni. I was at work.
Ngobeni.
I was only joining now.
No problem. I know the voices, just I don't know Sakane Ngobeni. Now I've written how many? 10 names already. And then the last one is sec. What is sec theta?
3 over root 5.
3 over root 5. 3 over root 5. Okay, so let's go. Those are the answers. There we go. Now they say special triangles. Can someone remind me the special triangles? The first triangle is what?
Isosceles.
45, not that one.
Right angle triangle.
45, 45. We did this, guys. So 45. This one, okay, let's start with degrees. This has 45 degrees and this has 45 degrees. Their sides are what?
That side is 1.
Equilateral.
1 and the other one is 1 and
root 2.
Yes.
And the other special angle is special triangle.
30 and 60.
60 and 30.
Remind me, so this is 60 and this is 30. And then 30. The sides are?
The lower side is 2 and then the other side
is 2.
And the adjacent is 1.
And then this one is what?
And then
3.
Do you see that we already did this?
Yes, ma'am.
So now they say there are special triangle ratios that can be calculated from certain triangles, which are called special triangles. We can also use a calculator to find these trigonometric ratios. But I say to you, use special triangles. Special ratios. Certain right triangles have ratios that can be calculated easily from the Pythagorean theorem. Since they are used frequently, we use the notation. Here's that triangle of ours. The first triangle is obtained by drawing a diagonal in a square. So they are telling you that you know that this is a square, né? And we know square, all sides are equal, isn't it? And then we know that this is 90 degrees, and this is 90 degrees, and that is 90 degrees, and that is 90 degrees. If you draw a diagonal like this, what will happen is the 90 degrees is halved, meaning that it becomes like this. So because then this becomes a 45, and this becomes a 45, and this becomes a 90 degrees. And this is 1, this is 1, so this is 1, this is 1. And then using theorem of Pythagoras, you get root 2. Now, the 60 and 31, we find it from an equilateral triangle. They say by Pythagoras, the theorem, this diagonal has the length root 2. So this one, they're just discussing the triangle up there. Now, to get the second triangle, we start with an equilateral triangle, right? What do we know about an equilateral triangle? All sides are equal. It means that if all sides are equal, all angles are equal. So these sides, if we give them 2, let's not give them 1. Let's give them 2, 2, 2, right? We know that this will be 60 degrees, and this will be 60 degrees, and this will be 60 degrees. If we draw a perpendicular bisector, meaning that we draw a line from the center here to this point here, where it forms 90 degrees both sides, it means that we have so this side will be 1, this side will be 1, which gives us 2, meaning that we'll have a triangle like this. Where, because here it's a bisector, meaning that it will be 30 degrees. If you have 60 degrees, you get 30 degrees. Okay, why is it not? So this is 30 degrees, and then this is that 60 degrees, and this is that 2, and then you have that 1 there, and then you can use Pythagoras theorem to get this 3. And because it's a perpendicular bisector, that's the 90. So these two sessions, they're just showing you how to find the triangles that we have been talking about all along. Are we together?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So these are the triangles here. And from these triangles, you can get those three special angles, which is the 30 degrees, the 60 degrees, and the 90 degrees, which is pi over 6, pi over 3, and pi over 4, which is, or the 45 also. So then you can go and play around with this table and see if you can be able to use these triangles here, but in radians to be able to solve this table there, as we did in the previous session. So that's why I say this session is more easier. Now they say using a calculator. In this case, we're not using a calculator in our module, but let's just read. To find the values of a trigonometric ratios of other angles, we use a calculator. Mathematical models called numerical methods used in finding the trigonometric ratios are programmed directly into your scientific calculators. That's why I don't want you to use a calculator. Calculators give the values of sine, cosine, and tangent. The other ratio can easily be calculated from these by using the reciprocal relation, meaning that if you have sine, you can find cosine by saying 1 over sine t. If you have cos, you can find sec by using 1 over cos t. If you have cot, you can find, if you have tan, you can find cot by saying 1 over tan t. So they say we follow the convention that when we write sine t, we mean that the sine of the angle whose radiant measure in t. For instance, sine 1 means the sine of an angle whose radiant measure is 1 rad. When using a calculator to find an approximate value of this number, set your calculator to radians mode. You will find that if you want to find the sine of angle whose measures in degrees, set your calculator mode into degrees. Didn't we do this?
We did, ma'am.
Thank you.
We did.
So meaning that we actually went and did this whole okay, so then you use a calculator because it's in degrees. You say tan 40, tan 20, cot 14, and cosec 80. You can go and use a calculator just to check, but I won't give you such a question because you're not allowed to use calculators in the exam. So then we skip those questions. Now we come to application of trigonometry. That's why I say if you understand your work, the other sections become very easy to you because you already understood the work. Okay, now the application of trigonometry of right triangle. Now they say the triangle has 6 parts, right? Now, if the triangle has 6 parts, it means that, so they're saying the triangle has 6 parts. It means that it has 3 angles and 3 sides. Now, if they say solve a triangle, they mean that you need to determine all of its parts from the information unknown about that triangle. That is to determine the length of the 3 sides and the measurements of the angle. Are you all together?
Yes.
Yes,
Yes, ma'am.
So then if I say so to you in the exam, solve triangle ABC, I mean that I want you to go find this side, which is A, this side, which is B, and sometimes I would even say angle B here, this side, which is angle B. So meaning that from here, how can we find A? How can we find A? How can we find B?
We can first find B, on which we already know the angle and one side of it.
Thank you. So we know the angle on one side of it, then we do what?
We use sine theta because it has the opposite side and the hypotenuse, and also we have the angle.
Thank you. So sine theta is equals to op over hypotenuse. So we know opposite is A over what? 12. So meaning that we want sine 30 degrees equals to A over 12, meaning A is equals to 12 over sine 30 degrees. So now we know what sine 30 degrees, isn't it?
Yes.
What is sine 30 degrees?
It's pi over
1 over
6.
What is sine 30 degrees?
5 over
1 over 2.
So it's 12 times 1 over 2, which is equals to 6. Am I missing someone? Because I've been hearing pi over 2, pi over. You have to know
No, we are
sine 30
together, ma'am.
degrees. Okay. Now, how do we find B?
So, ma'am, I think this one is we can use the
Cos 30.
special triangles where you say 90 plus 30 or minus 180, then you can get the angle B.
Not the angle B. We want the side B. Okay, let's
Yeah,
do angle B.
Ma'am.
Sorry.
You can also do that. It's a long way,
Yes.
but yeah.
Let's do the angle B. So angle B, we know that if angle B, this angle plus 30 degrees plus 90 degrees is equals to 180 degrees. Sum angles of triangles, right? Then you say angle B is equals to 180 degrees minus 120 degrees. So this is equals to 180 minus 120, that's 70 degrees.
60.
60.
60
Yes.
degrees.
My apologies. 60
60.
degrees. So this is 60 degrees. So we found angle B. Now we left with side B, small b. How do we find small b?
Can use
How do we find
Pythagoras
Cos
theorem.
30,
We can
ma'am.
use B,
Cos 30.
B
cos
over
30?
12.
Let's not go far, guys. Cos 30, Pythagoras is a bit longer. So cos 30 degrees is equals to what? SOHCAHTOA.
Adjacent over hypotenuse.
Thank you. Over hypotenuse. And we know adjacent is just the angle next to it, which is not a hypotenuse. So this is B.
over 12.
So B over 12. Meaning that then this is equals to B is equals to 12. What is cos 30 degrees?
0.
Root 3 over 2.
3 over 2. So meaning that this is what? 18. Am I right?
It's root 3 over
Cos 30 degrees
Root
is
3,
3 over 2.
yes. Thank you, root 3 over 2. So root 3 over 2. So meaning that this will be equals to 6 root 3. Are we all together there?
Yes, ma'am. Yes.
Thank you. Let's see. The first one. Yes, we are right. There we go. This is our 6. The second one. Are we right? We said 6 root 3. Well done. We had a mistake, but it fixed there. Thank you. Now that we're done here, we go to the next one. To discuss the next example, we need some terminologies. If an observer is looking at an object, then the line of eye of the observer to the object is called the line of sight. Do you see what the line of sight is? So apparently this guy is washing windows there and the bucket is falling and this lady's like, yeah, the bucket is falling. Obviously, you can't look down and say, yeah, the bucket is falling, isn't it, guys? So you're looking up. So that line is called the line of sight. This line here. Are we all together? Now, if you're looking up and then towards the horizontal, if you're looking up and it forms an angle with the horizontal, that's called angle of elevation. You are elevating your eyes to the sky. That's how you can remember it. Do you see that? Guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now,
Yes, ma'am.
the bucket falls onto this guy. Now she's looking down there. The line of sight changes. Now, if you draw a horizontal line from her eyes to this point, you'll notice that the angle now moves in it's more of like in the counterclockwise direction, basically, but not, right? So then we call this the angle of depression. To remember is that when you're depressed, you always face down. It's like yo. That's how you can remember it. Now, if the object being observed is above the horizontal line, that's what they're saying, this line here is above that line there, right? Then the angle between the line of sight and the horizontal is called the angle of elevation. If the object is below the horizontal line, then the angle between the line of sight and the horizontal is called the angle of depression. If the line of sight follows an object, a physical object such as inclined plane or hillside, we use the term angle of inclination. Are we all together?
Yes,
Now, there's an example here.
Yes, ma'am.
Can we look at that example and discuss it? What do you think? Remember, guys, these word problems will be there in the exam. You can't just write. You need to think about it. And in most cases, I give them like a 6 so that you have enough time, 6 minutes to think about that problem. So let's think about it.
So we are saying the shadow produced is the base, basically, like it goes flat, like horizontal, where the tree is standing a height. Then if we put a candle or a sun on top of an angle tree, it creates that shadow that goes maybe to the left of it. If it's on the right, the shadow goes to. If the sun is on the left, it goes to the right. So where the shadow and that line that goes to the sun, I think creates the angle.
So you're saying this is a tree, ne?
I'm just trying to draw the picture of the triangle.
Yeah. Let's start with the scenario. Oh, what am I doing? Okay. So there's a tree, isn't it? So this is a tree. Yeah, I'm not good with drawing, guys. So this is my tree, my kind of tree in my imagination. So where is the sun hitting in this case? Let's choose one direction. It's hitting the tree from the left or right. Let's say the sun is here.
Left.
Yeah.
Ne? So the sun is hitting the tree.
Yes.
So the shadow goes to the right.
So when the sun is hitting the tree, the shadow goes where? If the sun is hitting the tree from the left, the shadow goes to the right.
To the right.
The right.
To the right.
So meaning that the shadow will be here. Yes.
Did they say the sun, it is elevating when it is depreciation, it's going down, like it's depreciation, not. So
No
they
one-
say elevation.
It's because no one has stood on the sun to look at the shadow. It's always you are on the shadow to look at the sun.
Oh, okay.
Yeah. It makes sense now.
Yeah.
Okay. So meaning that now they're saying that the shadow is what? 532 feet, isn't it? Let's say centimeter. Are you all together?
Yes.
Yes, ma'am.
So meaning that the angle will be here. I know I haven't drawn it, but the angle of elevation will be this one. Are we all together?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So this is what?
Yes, ma'am.
25.7 degrees, isn't it?
Yes, ma'am.
Yes.
So what are we looking for?
The height of
We are
the
looking for
So we're looking for the height of the tree.
The height of the tree.
So meaning that to find the height of a tree, what can we do? We'll say what?
we'll use 10 theta because it's taller, it's opposite over adjacent.
Thank you. It's Toya from Soccer Toya. So meaning that it's 10 of 25,7 opposite, which is it opposite? What am I saying? Opposite over
Yes.
adjacent.
Correct.
Yes, ma'am.
Yes,
So
ma'am.
I was confused with this age, guys.
It's
Yo,
H. It's H.
It's H over 532.
532. So meaning that centimeter, meaning that H is equals to 532, 10 to 5,7. That's what we got, isn't it?
Yes, ma'am.
So let's check if it's correct.
Can I ask you before you check?
Mm. Yes.
I'm seeing on your diagram, you said it's 532 centimeter. Then on their statement it's 532 feet long. Which one do we have to deal with between the two?
Okay, so normally, especially for those who have been attending since from the beginning, you'll notice if it's in dollars, I'll say it's rands.
Oh yeah.
Yes, I use units, South African units, the ones we know. Do you understand? So maybe if it's in pounds, then I'll say it's in rands, or if it's the pounds of the kgs, I'll say it's in kg. So I normally do that. Instead of I go and say, because in the exam, I will give you centimeters, I'll give you kilometers, I'll give you kilograms. Yes.
So it's one thing, no, there's no convention or what?
No, I didn't do any convention here. I'm just
Alright.
saying that I'm cancelling the feet and I want to put centimeters.
I'm
See?
with you. I'm with you.
Yes. But if there were a convention, I need to go and say, yo, Konje, what is feet? What is $1 to a rand? And tomorrow you are right. Today, I tell you, $1 is maybe 15. Tomorrow you are writing the exam, you use 15, I give you wrong because the following day, $1 is 14. So I use South African rand, South African units, matrix units as well.
Thank you.
Okay, can we check now?
Yes, please.
Thank you. How? We got it. Well done to us. Well done. Well done. Oh, well done. So meaning that in our case, we'll say centimeter or kilometer or something like that. And we are done in the session.
Oh, this was fast.
It's because we covered these things before and we understood the work. So that's why it was very quick.
Oh, okay. Before you even close the slides, I've got another question, ma'am.
Yes.
You were too fast on the angle of inclination. I didn't even say the definition of angle of an inclination. Yeah.
So, ma'am, can I ask? So, what we worked right now, which was it, inclination or was it depression?
It was elevation. What we're looking at now. It was elevation. Remember, you can't sit on the sun and look down on us. You'll burn.
Yeah.
Do you see that? So when you are looking at, if there's a relationship between a sun and a shadow, it means you are there by the shadow and looking at the sun. You are here. And even if you're not really looking at the sun, but yeah. And you cannot be here and be there. Do you understand? So meaning that angle will say depression, but then you can't be here. But you're elevating your eyes to the sky. Do you see that? That's called angle of elevation.
Okay.
Yeah. Okay, I think I need to stop the recording so that then you can do questions. And then if there's I just want to give you guys, stop the recording.